right, so everyone who is, we're doing these notes for everybody who's gone to the art museum today. This is what we're doing in class. Section 2.3.2, slope review. We're not going to use our packet. We're just going to, since this is not brand new by any means, we just want to jot down some reminders. So there is an equation for slope. And the equation, if you remember, and slope is always m, I remember because of a mountain slope. The equation for slope is, if you're given 2 points, you take y2 minus y1 over x2 minus x1. That's because, and we're in class right now, I'm going to ask the class, does anybody know why we have our y difference on the numerator and our x difference on the denominator? Because it's, Johan said, the rise over the run. He's exactly correct. Okay, so our change, that delta means change in y. And underneath that is our change in x. And what that means is how far we're going up, or our rise over our run. So really quickly, if we're given 2 points, you guys shout out some of your favorite numbers.
8 and 7.
8, 7. And what's another point? 18 and 32. Okay, well, these are the two that we're using. So we have x1 and y1, and we have x2 and y2. And I've noticed in the past where there are issues, it's because people just aren't, well, I'll show you when we put it in. It doesn't actually matter which one's x2, which one's y2, or not x and y. It doesn't matter if you use 2 first or 1 first, but what you use first, if I use 32 first as my y2, right? So y2 is 32. Right underneath that is where I have to put the matching x value, okay? They have to be one right on top of the other one. So that's where we put 18 minus, and you don't have to put the second number in parentheses, but it really comes in handy if that second number is negative, because you would end up adding. But then we put the second y value, which is 7, and the second x value, which is 8. So 32 minus 7 is 25. And 18 minus 8 is 10. I can reduce that, though. I think 5 goes into both of these, which is 5 over 2. So we're going up 5 and over 2. Or you could turn that into a decimal if you wanted to type it into the calculator easier, which 5 divided by 2 is the same as 2.5. Okay, so that's, if you're given 2 points, that's how you write that, that's how you find your slope if you're given 2 points. Now, what does that look like? Don't yell at me, I'll put it right back. What does that look like in a graph? What that looks like in a graph is if, sorry for the wiggling line, if we have, this is 8 and this is 7, and then this is 18 and this is 32 way up here, right? So we have these 2 points. So how we view slope in a graph, right? If this is our line from this point to this point, our rise is right here. This is our rise. So to get from 7 to 32, we have to go up 25. And to get from 8 to 18, we have to go to the right 10. So that's where we get our rise, right? Our rise over our run. Okay? All right, so that's what it looks like That's what it looks like in a graph. Now if we take a look at the table, okay, where we have x here and y here, if our slope is 5, we've reduced to 5 over 2. And we know, we know that if we start with our x being 8 and our y being 7, that our y value is increasing by 5 and our x value is increasing by 2. So the next one would be 8 plus 2 is 10, and 7 plus 5 is 12. So 10, 12 would be another point on that line. And also 12, 17 would be another point on that line. And that's because the difference from 8 to 10 is 2, 2, and the difference from 7 to 12 is 5. So there you have your, and it looks different this way because our run is in the x value and our rise is the y value. So it's actually 5 over 2, but the way the table's written, it might be a little bit different. So there you have it. We have our equation, which was up at the top. You have what it looks like in a graph, and you have what it looks like in a table. I'm going to pause the video for just a second and ask the class if they have any questions, and then we're going to come back and take a look at the two forms of linear relationships. All right, so what does this look like in forms of linear relationship equations? There are two major types of equations that we talk about. The first one is one we learned in 6th grade. It's the, slope intercept equation. Okay? And obviously, we use that when we have the slope and we have the y-intercept. Okay? Makes it really easy. We talked about this last time in class also. So we have y equals mx plus b. We know how to find our slope. And this is just our y-intercept. Okay? The other one I want to talk about is point slope form. And we did do this in Algebra 1, but I know we never hit on it as much as we should, but it makes it a lot easier to use. We use this one when we have a point, right, and the slope, but we don't have a y-intercept. So instead of having to go back and solve the slope-intercept form for the y-intercepts, all we have to do is put it into this form. So y equals m, and m is still your slope, times x minus x1 plus y1. You could write it this way. You could also write it as, instead, y minus y1 equals m times x minus x1. I know what you're thinking to yourself right now as you're taking these notes down. I know what you're thinking is like, Miss, this looks so similar to the slope formula, so let's prove why this works. We know, we just learned our slope formula is m equals y2 minus y1 over x2 minus x1. Now, if I want to solve this for y2, I want to get y2 by itself, the first thing I'm going to do is multiply both sides by the denominator, which is x squared minus x1. So if I do that step, I get m times x squared minus, or x2 minus x1 equals, and then if I multiply it on this side, it just cancels out, and I get y2 minus y1. Then if I want to get y2 by itself, I just add y1 to both sides. So I have m times x2 minus x1 plus y1 equals y2. All right, so we got from the slope formula, we just rearranged it, and we have point slope form. Okay, so when is point slope form good? When we have a point and we have the slope. So you're going to need 2 points. First, you have to find the slope, and then you have to find a point. So if we are going to get 2 more points, guys, give me some numbers. No. -5, 7, and 6. Okay. x1, y1, x2, y2. We're going to put it in the slope formula. Oops, 6 minus 49 negative 11/43. All right, write this down. One last step. We found the slope. All we have to do is put it into point slope form. So we have, and up here, when we found point slope form, these 2's that we have here, these sub 2's just become regular x and y. So in point slope form, we have regular y equals, I'm just going to write this side first and then write it over here. Our slope, which is negative, and we pull that on the outside, negative 11/43 times x minus, right? And then what was, it doesn't matter actually if we use x1 or x2. Let's use the smaller numbers. X minus 7 plus, then we have to use our y value that comes from the same one, plus 6. So we don't have a y-intercept. If we simplified this, we could find a y-intercept if we just multiply this through and then combine like terms. But for right now, we're just going to keep it in point slope form. So what you should have, before this video stops, gotten out of this video is, what does slope look like if I'm given 2 points? What does it look like on a graph? What does it look like in a table? And you should also know the formulas for point slope form and slope intercept form and what you can find in them.